Students, I welcome you in today's session of physics, and in today's session we are going to discuss electric cell. This is the topic of your chapter number 7, which is electricity. As you all know very well, in our lecture number 1 we had covered most of the topics of this chapter. So now today's class we are going to discuss here what is electric cell or dry cell, or you can simply say just cell. Fine. So the dry cell was invented by a French scientist, Georges Leclanche. Who invented the cell? Georges Leclanche in 1868. An electric cell is a device which produces a small amount of electricity. The electric cell which we use in torch is commonly known as dry cell, or you can say just cell. It is called dry cell because it does not contain any liquid chemical. Fine. A common electric cell is shown in the figure I will show you. The electric cell is cylindrical device having a metal cap on one side and is metal disc on the other side. You can see here, this is your dry cell. This is the complete figure of your dry cell. Fine. So a dry cell consists, first one is your zinc container that act like a negative terminal. It is placed inside a painted tin container. Now the second one, zinc container is filled with a moist paste of aluminum chloride and plaster of Paris. It works as an electrolyte. Clear? So you have to remember what is used as an electrolyte in dry cell? Moist paste of aluminum chloride and plaster of Paris. Third one, a muslin bag with a carbon rod is placed inside the moist paste. Clear? Now the fourth one, carbon rod is used as a brass with a brass cap and act as a positive electrode. Fine. Empty space around the carbon rod is filled with which material? Manganese dioxide and powder carbon charcoal. I hope it is clear. The chemical present in a dry cell react and produces current. So the dry cell produces current till the chemicals are present in it. Fine. It is most commonly used in calculator, torches and many other electrical appliances. The electric cell has two terminals, a positive terminal and a negative terminal. The metal cap is positive terminal of the electric cell, whereas the metal disc in the negative terminal of the electric cell. Clear? So the positive terminal of electric cell is marked plus sign, whereas the negative terminal of the electric cell is marked with a minus sign. We can also say that electric cell has two ends. One is your positive end marked plus and the negative end marked as minus. So an electric cell has a number of chemicals stored in it. The electric cell produces electricity from the chemicals stored in it. Ordinary electric cells cannot be recharged. This is the most important property. The electric cells or batteries used in cars, cameras, mobile phones, etc. can however be recharged again and again for many years. Electric cells are used as a source of electricity in torches, wristwatches, alarm clocks, transistor, radios, etc. The shape and the size and types of cells used in various purposes may however be different. We also use electric cells as a source of electricity by performing science experiments in the school, laboratory. In our experiments, we should always join the two terminals of a cell by connecting them through the wires containing devices such as torch bulb and a switch, etc. We should never join the two terminal, means positive and negative, of a cell directly by a wire. Why? Because if we join the two terminals of a cell directly by a wire, only then the chemical present in the cell gets used by very fast. So the cell get damaged quickly and hence stop working. Clear? Now we will come to resistors. What is resistor? So those substances which have comparatively high electrical resistance are called resistors. Resistance is, I told you what is resistor. Resistors is a device which is used to stop the excess flow of current in an electrical circuit. Clear? So the alloy like nichrome, magnesium and constantium. You have to remember by which material you can make resistors. So nichrome, magnesium and constantium or Eureka are quite high resistance, so they are called resistors. Resistors are used to make electrical devices very high resistance is required. A resistor reduces the current in the circuit. So this is the main property of resistor. I hope it is clear. Now you can see here the electrical resistance of a conductor or a wire depend on the following factors. This is important thing you have to remember. You can see here there are the 4 points given. The first one is the length of the conductor. The second one is the area of cross section of the conductor or thickness of the conductor. The third one is the nature of the material of the conductor. And the fourth one is the temperature of the conductor. Fine. So the heating element or heating coils of electrical heating appliances such as electric iron and toasters are made of an alloy rather than a pure metal, because the resistivity of an alloy is much higher than that of pure metals, and an alloy does not undergo oxidation or burn easily given very high temperature. So when it is red hot, for example, nichrome alloy is used for making the heating element of electrical appliances such as electric iron, toaster, kettles, clear, room heaters, water geysers and hair dryers, etc. Now we will discuss about what is electric circuits. So a cell or a battery is a source of electric current, I told you, but this current cannot flow of its own. There must be a conducting material like wire, bulb, etc. between the two terminals of the cells through which electric current can flow. A continuous conducting path consisting of wires, bulb, switch, etc. between the two terminals of a cell or a battery along which electric current flow is called circuit. So this is the definition of electric circuit. From here you can remember this. Clear? So it is shown in the figure below. I will show you. In figure 7.9a we have a cell having a positive terminal, that is plus, and the negative terminal, that is your minus. The positive terminal of the cell is connected to one end of the switch with a piece of copper wire. The other end of switch is connected to one end of a bulb holder with another piece of copper wire. The negative terminal of the cell is connected directly to the other end of the bulb holder with a copper wire. The switch is on position or closed due to the circuit in figure 7.9a. I will show you where this is your figure. You can see here. This one is your on position. This switch is in on position, the bulb is glowing, and this is in your off position and the bulb is not glowing in this case. Fine. So the electric current make the bulb light up. You can see in the figure 7.9a, if we open the switch as shown in the figure B, the bulb will not glow if we open the switch. So due to this, one terminal of the cells get disconnected from the bulb and hence the current stop flowing. When the switch is open or off position, the circuit breaks and no current flow through the bulb will stop glowing. I will demonstrate you in brief. Here you can see this is the key, this one, this is your battery, fine, and this is your conducting material, or you can say it is an electrical appliances bulb. So when the key is closed, the current start flowing from the battery and reaches to the bulb, and the bulb will start glowing. But what happened in this case, you can see here, this key is in open state. Fine. Here it is closed and here it is open. So when the current start flowing through the battery, the current not getting the proper path to flow and reach up to the bulb. That's why the bulb is in this position is not glowing. I hope it is clear. That is the thing written here in this whole theory. From this point you can see that in this whole theory the same thing is written here. That's why I am skipping this and moving to the symbol for electrical components or electric circuit. What are the symbols used? So this is important one. In electric circuits we have to show a cell or a battery, switch bulb or lamp and connecting wires, etc. So to draw the electric circuit by making the actual sketches or drawing of the cell, battery, switch bulb or lamp and connecting wires is a difficult job. Clear? So the scientists have devised some symbols for electrical components like the cell, battery, switch, electric bulb and connecting wires, etc., which are easy to draw, and these symbols are used to draw electric circuit diagrams easily and clearly. So some of the commonly used symbols for electrical component in the circuit given below. Here you can see that These are the symbols, electrical equipment, their appearance and their symbols. So first one is their bulb. The symbol of the bulb like this. The connecting wires are represented by straight lines. The cell is represented by positive and negative terminal, and the battery, the combination of cells different is known as formation of battery. The switch represent like this. This is an open switch. And resistor, the resistor you can represent, this is the resistor, and in symbol you can represent like this. Fine, I hope it is clear. So circuit diagrams, we will now discuss about circuit diagram. So a circuit diagram we need to discuss a diagram which tells us how the various components in a circuit have been connected by using the electrical symbols of the component is called its circuit diagram. A simple circuit consists of a cell, clear, a bulb and a closed switch which was drawn here. You can see that this is the figure. This is a circuit symbol, clear. In this figure can be represented by drawing a circuit diagram shown here. In the circuit diagram shown in this 7.1a, a bulb has been connected to the two terminals of the cell by copper wires through the closed switch. This is a, you can see here, it is a closed switch. So this called closed or complete circuit, since there is no gap, therefore current flow in this circuit and the bulb lights up. Fine. Here you can see the key is also in the closed state. The current from this battery start moving through this key to the bulb, and bulb start glowing. But what happened, you can see here in the figure B 7.10, this one is the figure. Here the key is in open state and the bulb is not glowing. Why? The circuit is not completed. Clear? I hope it is understand. The electrical circuit consists of a cell, a bulb and an open switch. Fine. In the figure B1, I am talking about here B1. So represent the drawing a circuit diagram 7B. In this circuit diagram, a bulb has been connected by the two terminals of the cell by copper wires through an open switch. So this is called the broken circuit. Here this circuit is known as broken circuit. Due to the gap because of open switch, no current flow in the circuit and bulb goes off. Fine. I hope till whatever I taught you is clear. Now we will move to domestic electric circuit. Here you can see this is topic we are now going to discuss. So in domestic circuit, usually electric devices are connected in two ways. This is the important one. How will you connect the circuit in your homes? So there are basically two ways. The first one is your series circuit and the other one is your parallel circuit. So what happened here, you can see this is the series combination, this first one, this is series combination, and this one is your parallel combination. Fine. So what happened with the series and parallel combination? Which combination we were in our houses? So first you see what is series combination. So in series circuit, here this is the series combination. Each device is connected in such a way that there is only one path through which electric current can flow. Here you can see that the current starts flowing from the battery and reaches to the bulb. Both the bulb are in series combination here. Fine. So the current has only one path to flow. Now if we talk about this is the parallel combination, then what happened in parallel circuit? In a parallel circuit, all the electrical appliances are connected by means of parallel connections. Fine. There are multiple paths through which the electric current can flow in parallel circuits. So let us perform the activity to observe the behavior of appliances in series and parallel. Because in parallel combination you can see here the current has two paths, either it goes in this direction or in this direction. Fine. So there is an activity given here in your book. So it is the end of the chapter, students. We will meet in our next lecture with a new chapter. Till that, do study. Thank you class. Thank you very much.